Welcome to CO451 Networking. This is week 3, and this is the packet tracer for this week, which is Investigate the TCP/IP and OSI models in action. So we're inside the packet tracer exercise here, and this is the exercise that we have to work through. So we have some objectives, which part 1 is to examine HTTP web traffic, and part 2 is to display elements of the TCP/IP protocol suite. The background to the exercise is that this simulation activity is intended to provide a foundation for understanding the TCP/IP protocol suite and the relationship to the OSI model. The simulation mode in Packet Tracer allows you to view the data contents being sent across the network at each layer. As data moves through the network, it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. Each piece is assigned a specific name, Protocol Data Unit (PDU), and associated with the specific layer of the TCP/IP and OSI models. Packet Tracer simulation mode enables you to view each of the layers and the associated PDU. The following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on the client PC. Even though much of the information displayed will be discussed in more detail later, this is an opportunity to explore the functionality of Packet Tracer and be able to visualize the encapsulation process. So our instructions are: part 1, examine HTTP web traffic. So in part 1 as activity, you will use Packet Tracer, which we refer to as PT, simulation mode, to generate web traffic and examine HTTP. HTTP, Hypertext Transfer Protocol, is an application layer protocol. Step 1. Switch from real-time to simulation mode. In the lower right-hand corner of the Packet Tracer interface are buttons that toggle between real-time and simulation mode. PT always starts in real-time mode, in which networking protocols operate with realistic timings. However, a powerful feature of Packet Tracer allows the user to stop time by switching to simulation mode. In simulation mode, packets are displayed as animated envelopes. Time is event-driven, and the user can step through networking events. So part A, step 1A, is to click the simulation mode icon to switch from real-time to simulation mode. Then we need to select HTTP from the event list filter. HTTP may already be only visible event. If necessary, click the Edit Filters button at the bottom of the simulation panel to display the available visible events. Toggle the Show All Known or None checkbox and notice that the checkboxes switch from unchecked to check or check to uncheck depending on the current state. Click the Allow Show All None checkbox again until all the boxes are cleared, and then select HTTP from the MISC tab of the Edit Filters window. Click the X in the upper right hand corner of the window to close the Edit Filters window, and the visible event should show only display HTTP. So let's just go and quickly do that. So here's our Packet Tracer. As it says, it's in real time by default, which is the button down here in the bottom corner. You may also find that this panel is scrolled down like this. So just look for that arrow at the side there and click on it, and it will just roll that back up. If we then go into simulation mode, which is the simulation button there, this is where it stops time. And down here we have our event filters list visible events. And my one's currently saying HTTP. I do have an Edit Filters and I have a Show All or None button here. So if you click on Edit Filters, you can change what filters under the MISC tab are currently displaying. So there's HTTP, and that's the one that we want to display. We don't want to display anything else, and also nothing under IP version 6 or IP version 4. So just the HTTP filter is what we want to be able to see. And you can show all or none. So if I do show all none, that removes all the filters. That puts them all on, and they all appear in the panel here. And then if I go to Edit Filters, you can see that everything is ticked. So I'll just toggle them back to being none, and then come back into the MISC tab and select the HTTP on its own. and then just close the panel, and HTTP is selected just there. This is just a way of filtering what you see when the protocol data units are moving through the network. So it just helps to focus your attention on what you want to see. So we want to focus on HTTP, so we're changing our filters just to show that type of traffic. Let's go back to the exercise. So step 2 is to generate some web traffic, HTTP traffic. Currently the simulation panel is empty. There are 5 columns listed across the top of the event list within the simulation panel. As traffic is generated and stepped through, events appear in the list. Note the web server and web client are displayed in the left pane. The panels can be adjusted by size by hovering next to the scroll bar and dragging left or right when the double-headed arrow appears. So they want us to click on the web client in the far left pane, click the desktop tab, and click the web browser and open it. In the URL, enter www.osi.local and click go. Because time in simulation mode is event driven, you must use the capture forward button to display network events. The captured forward button is located in the left hand pane of the blue band that is being below the topology window. Of the 3 buttons, there is the one on the right. Click capture forward 4 times. There should be 4 events in the event window. Look at the web browser page. Did anything change? Click the first coloured square box under the event list type column. It may be necessary to expand the simulation panel or use the scroll bar directly below the event list. Well, let's go up to here first and get some web traffic going. So, okay, so we're going to go to our web client. Go to its simulated desktop. Look for its web browser. Open that up in the URL box here. Type www.osi.local. And we can click go. And it doesn't actually say, but leave that minimized. Don't close it, just minimize. And then over here, this is our capture forward button. So it looks like kind of fast forward. So if we click on that, and they suggest 4 times, that then gives us our returned information here. So in the event list, which we can just expand a little bit more out if it is a little bit in the way there, give us a little bit more room. We can see that we have these 4 events appearing here in our list. This is traffic that's being sent by the client to the server and has come back again. So let's see what they want us to do next. So we captured our events. So did anything in the client web browser page change? So let's just go back and have a look at the web browser. There we go. So it now says web server, you have successfully accessed the home page for the web server. So we actually got our web page back. So in the completion of that data send and receive, we got our web page back. So click the first coloured square under the event list type box, may miss expand the simulation tail, and it gets us to look at the protocol data unit information at device. Web client window displays. In this window there are only 2 tabs, OSI and outbound PDU details. Because this is the start of the transmission, as more events are examined, there will be 3 tabs displayed, adding a tab for inbound PDU details. When an event is in the last event of the stream traffic, only the OSI model and inbound PDU details tabs are displayed. So ensure that the OSI model tab is selected. Under the out layers column, click layer 7. More information is listed in number steps directly below the in layers and out layers box for layer 7. So this is the way that we actually look at our protocols and what's going on whilst network traffic is in progress. So the first point here, this is at the 0 point, was in progress. So I clicked on that, and this separate panel comes up. This is the PDU information at the device, the web client. And as it said, it has the OSI tab at the top and the outbound PDU. And if we're looking at this later on, we'll be looking at protocol data units which have an inbound as well. So we'll have an inbound tab up here. So OSI and outbound PDU. The outbound PDU shows as the TCP IP model, and obviously the OSI shows us our layers. And this is going out. So the first thing was a request going out of the web client towards the server. So our traffic started at layer 7 here. And if I click on layer 7, which I am, it says the HTTP client sends an HTTP request to the server. So that was us putting the address in and pressing go, hitting enter, to actually do a web request to the server. That data, that protocol data unit at layer 7, was passed down to effectively layer 4, which is transport. So a sent segment information, the sequence number 1, acknowledgement number 1, and the data length was 102 bytes. So that's it being packaged up to send across the network as a TCP. So TCP has a source port 1026 and a destination port which is 80. 80, because we're on the web client, 80 is the destination port on the web server. So that's the port that will be used for serving of the web pages. Port 1026 on this web client is essentially a randomly generated port above 1024. So we don't need to worry too much about that at the moment, but it's going to destination port 80, which is what the web server will be listening out for. That's its port for serving web pages. Layer 3, we have the IP headers. So we have a source IP address, which is 192.168.1.1. This is the PC, the web client. And the destination IP address is 192.168.1.254, and that's the web server. So again, it would have got that from DNS domain name service. That's something a little bit we haven't come onto yet, and we'll get to, but that has been populated there from another request. And then we have layer 2, which is the Ethernet 2 header. So the first address there is the source address, so that's the source MAC address. And then we have the MAC address of the web server as destination. And then layer 1, it's actually going out the Ethernet port. So that's the first thing it did. So what information is listed in the number steps directly below the layers? And so we've just been through those. What is the destination port value for layer 4 under the out layers? So destination port for layer 4, which is transport, is port 80. So 80 is the value because that's a web HTTP port on a web server. What is the destination IP value for layer 3 under the out layers? So destination IP address we can always find. Again, just come back here. So the destination IP address for this packet is 192.168.1.254, and this happened to be the web server because we're communicating in the same network, it's point to point. So 192.168.1.254 is the web server's IP address. So what information is displayed at layer 2? That's the MAC address details. So we have the source MAC address, which is the web client's MAC address, and we have the destination MAC address, which is that of the web server. Then it goes, click the outbound PDU details tab. Information listed under the PDU formats is reflective of the layers within the TCP/IP model. We should note that the information listed under the Ethernet 2 section of the outbound PDU details tab provides even more detailed information than is listed under layer 2 on the OSI model tab. The outbound PDU details provide more descriptive and detailed information. The values under destination MAC address and source MAC address within the Ethernet 2 section of the PDU details appear on the OSI model tab under layer 2, but are not identified as such questions. So what is the common information listed under the IP section of the PDU details as compared to the information listed under the OSI tab, with which layer it is associated. So let's just have a look at the difference. So we've got layer 2, Ethernet 2. So we just literally see details here. And under Ethernet 2, it tells us the next top IP address is unicast. The ARP process looks it up in the ARP table. The next top IP address is in the ARP table. The ARP process sets the frame's destination. MAC address to the one found in the device encapsulates the PD into an Ethernet frame. And under the Ethernet frame information here, we see source and destination MAC address. If we look at outbound PDU, here we see the Ethernet 2. So we have this preamble. We then have our destination address. So that's the address, destination, so the MAC address of where we are going to. We then have our source MAC address. And we have things like type and data variables. We have a cyclic redundancy check as well within that. So what is the common information listed in the IP section of the PDU details as compared to the OSI? Well, it's the IP addressing. And so in the Ethernet 2, the common stuff is the destination MAC address and source MAC address. Under the IP section, layer 3, it's the IP addresses, destination and source. What is the common information listed on the TCP section? That's the port numbers. So you will see that as well. Let's have another look at that. So so here's the IP section, and these are the destination and source MAC address. That's the source IP address, destination IP address. And if we come down TCP header, we've got things like sequence numbers, acknowledgement number, but we also have a source port and we have a destination port. So what they're trying to show here in the outbound PDU details is essentially all the bytes of the protocols, the headings for those. So these are what's being actually used when data goes over a network, essentially. In the OSI model, they're trying to give you a bit of reference for that, and they're just picking out the key information that we need and telling you a bit about the process that got to that layer. So the useful thing about the packet tracer tool here is that you get to see this broken down in terms of sending data out and receiving data, and it tries to get you to step through and see what happens at each part of the process. So these are things that you can't see in real live networks, of course, because it's all hidden inside the wires. It's just data signals going across. But here we're actually able to look through the packets as they're being sent, and they're described to us in the OSI. And in the outbound PDU details, or the inbound PDU be coming the other way, we get to see the fields of the protocols and what's in those important parts. So that's all really this exercise is kind of doing so far. It's just stepping us through this event. So what is the host listed under the HTTP section of the PDU details? What layer would this information be associated with under that? So the host part. Yeah, so we've got HTTP requests there, so that's the application essentially. So click last color square in the info column. How many tabs are displayed? Okay, so last. So comparing the information displayed in layers, click the inbound and outbound, review the tab. So it's just really getting you to have a look through the various different events. I'll close that one. Let's open up say this one. We can see with this one we've got an inbound and outbound. So this is on the web server, so at device web server from the web client as our source, and the message comes in, receives the frame on this side, sends out the frame on that side. So it comes in, receives the frame's destination MAC address matches the receiving port's MAC address, the broadcast address or multicast address. The device de-encapsulates the PDU from the Ethernet frame, then pass up to the next level. The packet's destination IP address matches the device's IP address or the broadcast address. The device de-encapsulates the packet, passes it up the chain. The device receives a TCP push acknowledgement segment on the connection to 192.168.1 on port 1026. Receive segment information, the sequence number is 1, the acknowledgement number is 1, and the data length is 102 bytes. The TCP segment has the expected per sequence number, and TCP processes payload data. TCP reassembles all data segments and passes it to the upper layer, which is layer 7, where the server receives an HTTP request. In response to that, it puts out its own, sends back its HTTP reply to the client. That's then passed back to layer 4, where it's added segment information, the sequence number 1, the acknowledgement number 103, and the data length is 272 bytes. As passed to layer 3, the destination IP address is the same in the same subnet. The device sets the next hop to that destination because it's in the same subnet. And then at layer 2, it does the next hop IP address is unicast. So the ARP process looks it up in the ARP table. The next hop IP address is in that table. So the ARP process sends the frame's destination MAC address to the one found in the table. The device encapsulation the PDU into an Ethernet frame, and then it goes out of the physical port at layer 1 as a bit stream. So in part 2, we're displaying event elements of the TCP/IP protocol suite. So in part 2 of this activity, we use the packet tracer simulation mode to view and examine some of the other protocols comprising TCP/IP suite. So to view additional events, close any open PDU information windows. In the event list filters, visible filters section, click show all none. What additional event types are displayed? These extra entries play various roles within TCP/IP, address resolution protocol, ARP requests MAC addresses for destination hosts. DNS is responsible for converting a name, for example, www.osi.local to an IP address. The additional TCP events are responsible for connecting, agreeing, or on communication parameters, and disconnecting the communication sessions between the devices. These protocols have been mentioned previously within the presentation and will be discussed as our module progresses. Currently, there are over 35 possible protocols event types available for capture within Packet Tracer. So let's just have a quick look at all the other protocols that were in use. So show all here. You can see these are all the other protocols that were captured as well. So the use of DNS. DNS is for domain name services. In order to get the IP address of the web server, the web client had to do a DNS query. So it had to send a DNS request to a DNS server in order to find out the IP address of the web server from the address that we used. So we put in www.osi.local, but that is an address that can't be used to send information across the network. We need an IP address. But so we have to do a translation process using domain name services for that. And this is the information that was sent for DNS query. And this went on from source port 1025, destination port 53, which is the DNS server port. And it was sent out to destination 192.168.1.254. So the web server is actually is providing DNS information as well. So it's also a DNS server effectively. So this request was sent to the web server first in order to get the address for the web server So that's returned. We've also got an ARP. So ARP is all about requesting target IP addresses. So in order to communicate across the network, you need to get to the destination IP address. You need its MAC address in order to communicate. So address resolution protocol is there to get the MAC address of the end device that you want to go to, or the next hop device that you're going to next. So within this connection, we've only got a single connection from the web client to the web server, so we need the MAC address of the web server. So ARP is responsible for going off and getting that. So ARP request is sent out as a broadcast. This is why if we look at ARP operates at layer 2, so it doesn't have any upper layers, and it uses ICMP, so it uses ARP as such. So ARP has a specific source address, which is a broadcast address, so a destination address, which is a broadcast address, broadcasts itself out onto the network and locates the device with the matching IP address that it got from DNS in order to work out its MAC address, or retrieve its MAC address as a reply. So these are those packets going out. This is the DNS going out. And then we've got return on the ARP. So this is the web server replying to the web client in order to provide its MAC address as an ARP request. Reply to that. And then we've got DNS coming back from the web server there. So from the web server end, it replies with DNS in order to resolve the domain name into an IP address. And we then also have TCP. So TCP is Transmission Control Protocol. This is the protocol that needs to establish a handshake between a communication channel between these two devices. So ARP simply gets information about the MAC address. DNS gets information about the IP address that relates to that particular domain name that we put into the browser, and TCP is controlling the establishment of a connection between, although it's connectionless, it's between web server and the web client. So this says I want to effectively tells the web server I want to talk to you from the web client, and it manages the conversation that's taking place between them. TCP has a three-way handshake, so there's 3 different connections going on between it. So we have one from the web server to the web client from the web server, and then a reply from the web server to the web client, and finally a web client replies to the web server saying that's fine, we're acknowledged, and they synchronize themselves around the data that they're transmitting backwards and forwards. So TCP runs. Then we see the HTTP. And then once the data has been exchanged and we've received our web page, then TCP comes back into the process again and ends the communication. So it managed the conversation, and then it ends it by, again, a three-way process saying I want to end my conversation with you, from the web client to the web server. The web server says that's fine, let's end our conversation, and the web client then says great, we're out, and acknowledges that final acknowledgement to say that we're done with the communication. So lots going on. The interesting thing about this is when you start to look at what's happening inside the wires in networking like this, you suddenly realize there's more than meets the eye. So we just looked at HTTP initially with the filter being on for HTTP, and it looked quite simple. We just simply sent a request to a web server, it sends some information back, job done. But actually what was really going on was we were doing few more protocols. So it was DNS to resolve the web address into an IP address, and there was ARP, which was being used in order to resolve the MAC address for the destination that we wanted to reach as well. And we then also had TCP managing the whole conversation and making the connection between the web server and the web client, so that information for HTTP could be sent backwards and forwards. So I think our little exercise really just focuses on that. So so it tells you that TCP manages the connecting and disconnecting information. So it just asks a few questions. So this simulation provides an example of a web session between a client and a web server on a local area network. The client makes requests to specific services running on the server. The server must be set up to listen to a specific port for a client request. So yes, so the port it's listening on is port 80. So certain ports are reserved or aligned to certain services on web servers. So port 80 is for HTTP web server. So based on the information that was inspected during the packet tracer capture, what port is the web server listening on the web request? That's port 80. What port is the web server listening to for the DNS request? So DNS is 53. So we can see that as a reserved port there. So if I have a look at a DNS query, for example, you can see this is coming back from the client. So this is source port 53. So 53 is what the web server is listening for. And perhaps if I go to the first DNS, might be easier to show that. So here, UDP source port 1025, again a random port generated by the web client for starting the communication above 1024. But the destination port is 53, which is a specific port for DNS services on a web server. So these port numbers are known to a certain extent. So we've got some quite specific ports that you'll get more familiar with. So port 53, DNS, port 80 for HTTP. And that's it. So this little exercise is just about exploring the simulation mode. Have a look through it. It is about being sort of very detailed. Work your way through the packets. It does describe exactly what it's doing here. Obviously outlay as you go from 7, 4, 3, 2, 1 as you work your way through. And then if it's coming inbound, if you've got inbound layers as well, then obviously they go from 1 upwards, 1, 2, 3, 4, depending on what it is. So in this particular case, we've got an ARP. So an ARP never gets any higher than layer 2 because it's a layer 2 protocol. So it's just operating there. Obviously it's an application protocol like HTTP. Then you'll find going up to layer 7. It doesn't always show you the session and presentation layers and so on in the OSI view here. They are there, of course, in the real world. But they're not so important to us. What we really want to see is things like the MAC address, the IP address, the port numbers, because that's really what we're concentrating on in terms of knowing what the networking protocols are doing. The application protocol itself, what it does in terms of session presentation and so on, are less important to us in networking because the protocols that drive the network and get things across them are really layers 3, 4, and 2, 3, and 4. Those are the ones to concentrate on. So hopefully you had a little explore. This probably just gets you started. Try sending some web traffic. To clear this list, by the way, you can just come down to the bottom panel, and if you just click delete, it will delete the whole thing, and you can go back. Let's just bring up the web client again, and we can just click on go. And remember to minimize that. Don't close it. If you close it, it ends the process. So here you can see the first step, the DNS query. And if I step forward with capture forward, you can see it sends up to the web server or DNS server, and then we get our response back, and then it starts TCP. And then TCP establishes a three-way handshake. And then as it's going back for the third time with TCP, it also starts off the HTTP here for the transporting, and then HTTP follows on. All the way back. This is TCP closing down the connection. There's the HTTP, so the website has been delivered. And then TCP with three-way closure of the connection. So the final acknowledgement, that one, and that's that connection closed. So the nice thing about this is you can step through the process, see the information going back and forth, data going back across the networks, and you can examine each part of that, each protocol part, each protocol data unit to a certain extent within the window here. It allows you just to see it and have a look. So do get yourself familiar with that, because it's really useful to be able to examine packets and see this simulation in action. Like I say, if it gets a bit clogged up, just do delete and it will clear it. and then you can start again effectively. To go back to real time, just click real time button, and it will jump you back into things where just moving at real time space. So hopefully that was just useful to explain a little bit about Packet Tracer, get used to using the simulation mode, get you exploring how data is being used by the protocols across it. It does take time to kind of get this built up in your own head, how the application layer sits, how the transport layer sits, how network and the data link layers sort of sit together, and how the protocols work. So it's not going to take you, it's not going to be sort of instant. It does take a bit of time, but this is basically the structure that we use in order to move our protocols and move data across our network. So hopefully that's the start of the journey there. And using the simulation mode will hopefully make things a lot clearer in terms of what's actually happening when your networks run. So any network that you build or set up, you can always move into simulation mode and explore when you're communicating across it, when you're doing pings or just like we're doing now, a web request, you can see the information actually flowing backwards and forward, and it describes what's happening at each stage of the process. The thing to note about protocols is they all work in the same way. It's a mechanical, we're talking about machines here, so they'll use the same protocols again and again and again. So once you understand how a protocol works, you've got it. It's not going to change. That is the set of rules that govern that part of the process. So once you understand the single protocol, it kind of comes together in the jigsaw puzzle of what going on. So TCP, DNS, HTTP with the free, ARP, the four sort of protocols that we're looking at there. ARP runs every time, as there's a lot of things use TCP or UDP. So TCP, transmission control protocol, or UDP, which is user datagram protocol. So this is these are two different transport protocols that we would get to know quite well. So so anyway, have a little explore with that.